Yes. So let's have a game. Arrange the scrambled letters. So for the first one, arrange it. And the answer is electricity. Next letters. Okay. The answer is inductors. Next letters you need to arrange. And the answer is power. Congratulations everyone. Okay, so let's proceed to our topic, which is a power law. Now, let's have our objectives. After the lesson, 90% of the students will be able to. Power. When voltage causes electrons to move in a circuit, work is being done is called the electric power rate and is measured in watts. Power can be defined as the rate which energy is dissipated in a circuit. The total amount of work done may be accomplished in different lengths of time. For example, a given quantity of electrons may be moved from one location to another in 1 second, 1 minute, or 1 hour, depending on the rate in which they were moved. In all cases, the total amount of work done is the same. However, when the work is done in a short period of time, the instantaneous power rate or wattage is greater than when the same amount of work is done over a longer period of time. So now let's have the person who invented power, coming from the name James Watt, Scottish mathematician born on January 19, 736, died August 25, 1819. So he is the genius one who also discovered or invented the steam engine before. So that's him, James Watt, the inventor of steam engine that come into life before until now. Okay, so for the basic unit of power is watt. So let's proceed now for the formulas shown on the videos and on the screen. Please take note all of the formulas because we're going to use that later on. So for example, I stays with the current or amps, E equals volts, and we're going to look for the power. So here's the answers right beside of the example. Multiply the current times volts to get the total amount of the power or the watts. So for the next example, we have amps, I equals amps, then resistance into ohms, then we're going to look for power. So here right beside is the answer of that example. Just multiply the second power of current times resistance, then you're gonna get the total amount of power to 12 watts. Okay, so let's proceed for the inductors. And now let's have the questions. What is inductors? So we have here the two main points. An inductor is a device that stores energy in a magnetic field when electric flows through it. And second is opposes changes in current called inductance. Okay, so let's proceed to the principle of inductance. Now, the basic principle behind inductance states when a current flows through a conductor, it generates a magnetic field around the conductor. As the magnetic flux lines build up, they create an opposition to flow of current. When the current changes direction or stops, or the magnetic field changes, an electromotive force or EMF is induced back into the conductor through the collapsing of the magnetic field. The opposition to the changes in current flow is identified as counter-electromotive force. Now, all conductors have some inductance. The amount of inductance depends on the conductor and the shape of it. Straight wire has small amounts of inductance, whereas coils of wire have much more inductance. Let's have that the unit by which inductance is measured as the Henry or H, and the symbol for inductance is L. So let's proceed now for the types of inductors. First one is the variable inductors. A variable inductor lets the user control the inductance by changing the position of its ferrite core. Moving the core deeper into the coil increases the permeability, which increases the inductance. So that's how the variable inductors works. And let's proceed for the next one, is namely air core conductors. Air core inductors or inductors without core material, as you can see in between, are used for up to 5 millihenries on a ceramic or pheneric size. Next one is iron core inductors. Iron core inductors utilize ferromagnetic materials that significantly increase the inductance of the coil. Ferrite and powdered iron cores are used for up to 200 millihenries. Next is toroid core inductors. Toroid cores are donut-shaped and offer a high inductance for small size. The magnetic field is contained within the core. So that's how the toroid core inductors is. So for next one is cold shielded inductors. Shielded inductors have a shield made of magnetic material to protect them from the influence of other magnetic fields. That's why they have a shield around their body. That's it. And now we have laminated iron core inductors. These inductors carry from 0.1 to 100 henries, the inductance depending on the amount of the current flowing through the inductors. These inductors are sometimes referred to as chokes. They are used in filtering circuits of power supplies to remove AC components from the DC outputs. Now let's have for the activity. Answer the following problems using the given formulas that we have discussed earlier. Okay, for the number 1, answer it properly and think about the answers. Okay, all of the activities are all done. Now let me share some insights. The power law, also known as the Pareto principle or the 80-20 rule, describes the phenomenon where a small proportion of variables or events have a significant impact or outcome. This concept is observed in various domains, from natural phenomena to social economic systems. James Watt's improvements to the steam engine showcased the significance of power in driving industrial progress. While the term power law typically refers to a different concept, Watt's work on power and efficiency paved the way for major advancements in engineering and technology. His work on power and efficiency transformed the way we harness and utilize energy. James Watt's groundbreaking work on the steam engine and power continues to inspire innovation and shape the world we live in today's and in the future generations.